Welcome to this class, and today we will discuss about object-oriented programming. These are the topics which we will be discussing in this class. The first topic is instance versus class attribute. So in last class we have discussed what exactly object-oriented programming is and how we create classes, object and objects attributes, their properties like state, ID, behavior. So those we will extend now. So when we are talking about instance versus class attributes. This is the state of instance or object or class. We will discuss that in detail. Then this is the second topic, object creation and inspection. So how exactly you create the object and you can access the properties of object outside the class. Then there are instance methods. So there are three types of methods in object-oriented programming in Python. Instance method, which is object related, it's associated to object and class methods. Then we have static methods. So we will discuss those. And then one of the object oriented property we will discuss in this class, inheritance, and where we will have couple of classes. So this is one of the diagram I have shown here. So let's say you have base model abstract class, linear regression, linear class, logistic regression class, random forest class, and pipeline class. So you have couple of classes here and they are able to use their properties, like they can inherit the properties of each other, so you know no so you no need to write the properties again. So the help of inheritance, you will be reusing the code throughout the classes or subclass concept. So we will discuss that in detail. So before moving to the topics, I would like to call about quiz 11, and this quiz is having 10 questions and each question have 4 options. Out of 4, 1 is correct. It's MCQ type. So you do the practice of this quiz, and this quiz is based on the function or the topics which we have covered up to this class, and each question has 1 mark. So you can see like this the points. So the link of this quiz will be available in the comment box. So in last class, we have discussed how we create the classes. So we created fruit class and we created object of the class, and then we have added couple of elements to it, attributes to it. So there are attributes var1 and var2 in constructor. So what exactly constructor is? It gets called at the same time when you are creating the object. So whenever I create the object, it gets called automatically. The other methods, when we are passing here self, then these are the associated to the object. So similarly, we created a class A here and then couple of methods we created. So methods are nothing. Similar like you create the function in functional programming language, these functions I'm putting inside the class and then it becomes method. So the behavior is same, like you can write the code within that method and that is reusable code. So now let's create one more class and we'll understand better. So how to create class? It's simple. Just put a class keyword and let's suppose class name is model. So this class name can be any name. So I've just created a model here, model class. And then this is a constructor. So what constructor is? It is fixed underscore underscore init underscore underscore. So this is a fixed name and it will get automatically call whenever we will create the object of this model. So now let's say uh, we need to define a self here. So if I print here, print model object created, and then if I create the object of this class, so you can create object like this. Let's say m1 equals to model, the class name, and then parenthesis. So you can create n number of objects. Let's say m2 equals to model. So I created 2 objects here, and if I print both the object, then it will return, so let's say type of M1 comma type of M2, and then I say print M1 comma M2. So here's the output. Yeah. So here's the output. Model object created. So if you see, this is the constructor got automatically called when we created the object. So we are not calling it externally, or we are not calling it using object. Right. So that is the beauty of constructor. And here, if I say type of M1, then it returns the model class. So this object is model class object. So this is the way you create the class and object. Now, if I want to create another function, let's say I'll create method here. So same thing, whatever function you have created till like up to the functional programming language, same thing we will be creating here. So let's say def predict. So what this function does, it will predict something on the based on the model, and this is the variable self which will be associated with your object, and then you can pass variables. So let's say data. So now what is the difference between init and predict? So this predict is a method which we call a instance method. So you can call this method using instance. So instance and objects are same. Okay, there's no difference between. So let's suppose I want to call predict method. So even though I have defined it here, but I haven't called it. So if I run this, there is no output at all. So this is the output. So whenever I need it, we can call it using method. So m1 dot. This is the way to call the property of object. So now m1 dot predict, and I'll pass some data. Let's say some sample data 1, or m2 dot predict sample data 2. So if I'm calling these methods, then this is the output. So we are able to call the method defined in the class using object. So these methods, predict method called instance method, okay, or object method. So in object lifecycle, how exactly a object got created, and then there is a middle phase is uses and the deconstruction. So constructor we whenever we create the object, then constructor get called in. So then you can do the job, whatever methods you have write, you can use those methods. And then there is a method called del, which gets called in automatically when we are destructuring the or deleting the object. So how exactly it works? Let's suppose I create a class fruit, and then these are the two methods which will be automatically get called. So let's say if I create one object f1 of fruit class, and I'm not calling it externally, either I'm not calling init or del. So what happens is, see here, whenever you create the object creation will happen through the constructor, and this is called destructor, constructor and destructor. Right. So once the job is completed, then this del method, the uh, like deletion of the object will happen using del function. So these are the these are the two spatial methods which play a major role whenever you create an object, right? So I created the object of fruit class. I pass this value apple, which went to this field. Self is reserved in name, and then we created another variable self dot name equal to name. Like, even though if you don't want to pass any data as of now, we will remove it. So let's understand first how the life cycle works. So object, whenever object gets created, the constructor will be called automatically, and then this is the method will get called when we delete the object. So this will happen automatically. The Python compiler does it. So you no need to call this del special method externally. So let me remove this also because we don't have any argument. So like this. So let's say if I create another object f2 of fruit class, then again you see object created, destroyed, destroyed. Now you can create different methods in between of these like creation and deletion. So let's say if I say def set name of the object, I'll say like this self and name. So self dot name equal to name, and then I'll create another method get name. So this is just a method and which will return the name of the object. So let's say now you can use n number of methods. You can define n number of methods here and you can use for the object. So let's suppose if I want to use first set name, I created the object here f1. I'll just remove f2 here. Then now f1 have the properties set name and get name both. This is called instance methods or we call it object methods. So how you call it? F1 dot set name, and then you can pass the value here. This value will be assigned to name variable, not this. This is again it's a reference of your object. So this value will be assigned to name and then you are printing here. So if I call this, so this looks like now object created automatic call at constructor, then name set to Apple, which I have called it externally. Until you are using the object, you will be able to use the properties. This deletion or the object destroyed will happen at the end of the like the job is done for this object. Now the deletion will happen. Okay. That is why you see here at the end object is destroyed. So now I don't use after this I didn't use it. So let's say if I want to use it again, so f1 dot get name, again you see this. So you are able to use the method calls. So you can define your method calls or you can define n number of methods here and you can use them. So that is the beauty of this. And the life cycle of object also goes like this. So let's say first creation will happen, object creation is done in constructor. Then the usage of the object methods or method calls, we call it method calls. And then this is the final object got destroyed. So this will happen automatically. So you no need to worry like if you have created thousands of objects, for all the objects same behavior. So your memory is optimized. There is a one way like you can delete it automatically also. Let's say if I say del, instead of automatically manually also you can delete. So you can use del keyword here. So if I say del f1, then also it will work. So it's up to you. We have already automatic function to delete it, the deconstructor, and you can delete externally also like manually also. But this is not really required as of now. In this scenario, in interview they ask like at the time of object creation, this is the process should be executed, and at the time of object deletion, some process should be executed. So you can define that process here. You can define the logic here. So let's say print define logic to execute when object is created. And something here you can define the logic when object is destroyed. So at the end, so this should be automatically called when the object is deleted. So you can leverage these two methods constructor and destructors. And these are the special methods. You cannot define another name. This is fixed for the compiler. So whenever you want to use it, you should be using same way. Underscore underscore del underscore underscore. So let's try to use how exactly this deletion happens. So let's say I'll import time and I'll put a sleep of here maybe 20 seconds, and then still I'm using F1 here. So now let's see when this deconstructor or destructor will get called. So here it waits for the 20 seconds, and up to this object is not destroyed. So it waits till your program gets completed. Until that it holds it. Right. Then I am printing again F1 means the object F1 is live, it's available to use. Once my program is completed, then only the object destroyed, the deconstructor got called. The object is destroyed. So this object is available to use across your program if your program is running. Once the program is completed or the execution of F1 is completed and there is no call now, then it will be deleted. So let's suppose if I created F2 now, F2 fruit class. So now we will say F2 dot set name, let's say banana, and then get name. Then again I am printing here F2. So if you see, I'll just comment this section. What happens is this constructor, the del function, this got called at the end of the execution. Means F1 is available until here, until your program is completed. So if you see this, you have created F1, F1 is live now. You have created F2, F2 is live now. So whenever you created the object, constructor got called automatically for the both the things. Now F1 is doing its own job, F2 is also calling their functions, and it is both are the live now up to this. Once your program is completed, then the deconstructor gets called automatically. So if you see here, both the object got deleted at the same time. So however, you create n number of objects. Let's say you created a 3 or F3 object. Now I'll use F3 here. Then I say print F3. So again you see here all the 3 objects got deleted at the same time. So the object is available until your program is live. Once your program execution is completed, the function the del function will be gets called automatically and it will delete all the objects. So that is the behavior of this constructor here. So let's try to delete F1 here. The work of F1 is completed. Now I'll delete it first. So I'll keep it here, maybe like here. So no need to make it alive. So if you see, if I execute it, then object created and yeah. So here it got called. So the constructor got called here. So manually you can trigger it. So if you are not using the object, you can manually call the constructor and the constructors will be gets called and it will be done using del keyword. Like to summarize this, in case if you are not using del keyword, all the objects are alive up to your program is running. Right? And if you want to delete some of the object, you can use del keyword to call it manually. Now let's understand what is instance variables and class variables. So first we will understand the instance variables. So let's suppose you have a class, let's say car. Now in this class, I have a constructor, or let's say I'm not defining any constructor. I'll define a method called, let's say, model, and then we'll pass here one variable called model, and then I'll say self dot model equals to model. So what we are trying to do is we are just creating the scope of this variable to use in another methods. So let's say this is one method model. Now if I say def calculate cost, so let's say self and base cost. So there is, let's say there is a base cost to it, base price, maybe you can use base price. This is another variable, and the total cost will be calculated based on base price plus 1,000 rupees. So let's say if I write like this, if self dot model equals to BMW, then this is the cost. If, or I say elif self dot model equals to Audi, then the cost will be base price plus 2,000. And then for others, I'll say else the cost is base price. So I'm not putting any additional charges. Now we are just printing here cost. So let's create one object or an instance. So I'll create one instance, let's say obj1 equals to car. This is the object. Now I will set model to this object obj1 dot model, and I'm passing here BMW. Okay. So now if I say obj1 dot calculate cost, so I'll pass a base price here 10,000 in case. Then if I run this, the output is 11,000. Why? Because I have passed a model here BMW. So now this BMW value will be assigned to model, this field, and this is one of the variable which is the scope of this variable will be within this method, model method. So I cannot access this model outside of the model method. So let's say if I don't use this self.model and I try to access model here instead. So I'll say like this, it will give error. Why? Because I'm trying to access this model variable outside of this method in other method. So if I want to share the uh, attributes or variables among methods, so that is where I need to associate it with self. So self is nothing, it's the reference of your object. So I'm saying this variable, a model variable which I created, is associated to object. Now the scope of this variable has increased. So the meaning here is I have another variable, maybe this I will say model 1 to avoid the confusion. So this model 1 variable have capability to share across all the methods. So now I say self dot model 1, I created a new variable. This variable is instance variable. So whatever variables are associated to the instance, those are the variable called instance variables or object variables. So in this case, model 1 is the variable which is associated to your object. Now I am able to use this variable in another method in calculate cost. How we are able to use it? Self dot model 1, self dot model 1, like that. So let's say if I want to define another variable also, you can do that. Self dot, let's say color, and I will make color fix. Let's say black. Right. Now this color, this is another variable. This variable again instance variable. Why? Because it is associated with the instance, with the object. And let's say if I created another variable, I say let's say branch or maybe city. Let's say Delhi. So or I'll say available city. Right. Available city is Delhi. So if I define this variable like this, available city is Delhi. So I will be able to use this variable available city within model function. So I cannot use this available city attribute or variable into calculate cost because this is not associated with the object, with the reference. So if I try to, even though if I try to access it, if I say print available city, so it returns an error. It says this is not available. The scope of this variable is not outside of this method. This is local variable for this method. So that is why I am using that. So here I'll put I'll comment out. So now self dot color is also associated to the method or to the object. I'm doing self dot color. So this also can be used here. So I can say the cost of car is cost, and I'll say print the color of car is self dot color. So I'm able to access color variable from this method to this method. So black. Now if I created another object, let's say obj2 equals to car, then I say Audi, and I'll pass the base price is let's say 20,000, and similarly for Toyota. So you see here the common is black. The color is black now for every car. This value will be calculated based on this logic, but self dot color, this is the data which is common because I have fixed it here. This is not the variable. The data is not varying here because we are not passing it while calling it. So during the method call, we have only one variable which is model. In case if you want to pass it here, you can create another variable, let's say color, and you can mark it black is a default value. So now instead of defining this, you can say like this, self dot color is color, right? Self dot color is color. So now if I want to pass a color here, let's say for Toyota, I will say color equals to white, then it will work like this. So now dynamically you are able to define the value to the instance variables like this. You can define static value also. Both the ways are available, and you have local variables. So whenever you define any variable, you think about the scope, how you want to keep it. If the scope of variable is within the method, you define a local variable. If you want to increase the scope of the variable across the object, then you associate with the object, say self dot, then the variable name. So this is the way you create an instance variable. So let's suppose if you want to create some of the variable specific to the object, means those variables are not available in another objects. So if you see here, obj1 have model and color, base price also, because we have associated base price. No, this is not there. Okay. So these are the two attributes or the variables available in each object. If I ask, let's say print obj1 dot model 1, obj1 dot color, similarly obj2, obj3. So all three objects are having same number of instances because of this association. This is generic association. So whenever you create the object, these variables are available to use for all the methods, for all the objects. Obj1 is also having same property, obj2 is also having same property, obj3 is also having same property. Now let's say if you want to create variable specific to the object. So you can do that. How you can do that? Obj1 dot, let's say I'll give maybe um any variable. So let's say type. So type equals to sudden. So if I print obj1 dot type, so you have here sudden. This variable is available for object 1. Now if I say print obj2 dot type, so this will return error. Why? Because the type variable is not generic. It is specific to obj1. So you cannot access from obj2 or obj3 because this is not the part of your class. So object is the physical entity of the class, and this is the blueprint. So whatever blueprint you are defining here, all properties of this blueprint will be available in all the objects. But if you want to define a specific property to object, you can do that. So here we have created a variable specific to obj1, and the scope of this variable is within this object. The other object cannot use it. So either if you are accessing using obj2 or obj3, then both will give error. So like this. So you can define, but that is specific to object. So now let's discuss about class variables. So I'll create another um, example. Let's say class data loader. This is something relevant to AI. And now this data loader class is having, let's say, init, a constructor, where we are passing source. We are saying self.source data loader object created. We are just printing it, and there is another method load data, which is a regular method or uh, instance method, right? And we're just printing the source. That's all. So now when I created the object, let's say dl1 equal to data loader, and I pass the source here CSV. So the value of source will go to here, and then this is instance variables source self.source. So now if I print dl1 dot load data, so then it will print the loading data from the source CSV or JSON. So it's like similar kind of example we have taken here. We have taken a car, now we have taken another class, data loader class. So if I say what is the instance variable here, the instance variable is source, self.source. This is the instance variable or object variable. Now you can create class variables outside of the method. So that is one way, or this is a like basic syntax. Whenever you want to create a class attributes or class variables, they should be outside of the uh, any method and after the class. So let's say I have default, um, let's say default underscore batch size. So default batch size is 32. Just a variable. So you can define n number of variables in this space. So these variables are called class variable. Now the beauty of these variables are whenever you uh, create any object, or you can use this variable directly from the class also. So these variables now available to share across all the methods. So now let's say default batch size equals to 32, and then I'll define, let's say, some load data is here, data load. So I'll say like this, let's say self dot data equals to let's say data loaded from this. Now self.data is another instance attribute, right? Now I'll create or I'll use this here default batch size. So I'll say like this, let's say print my, or we'll say batch size is, so if I say self dot default batch size like this, see the output what it says, 32. So you are able to use this variable from the class, but instead of using self, so there's a confusion now. You think like I have self here, and self is mostly used for instance attributes, and this is class attribute. So what you can refer is, you can refer with the class name data loader dot default batch size. So you can access default batch size here in any of the method now. In load data, or maybe you want to use an init, you can do that. So let's say print, if I directly also write like this default batch size, then what will happen if I write without any reference? If I say like this, so it will return an error. So whenever you use it, so use with the class name data loader dot default batch size, because these are the class variables, so that you will be able to easily, whenever you are reading any code, or let's say you have written the code, someone else is reading your code, so they should be able to understand it. Okay, this is the class variable and you are using with the class. So this is within the class using it. Now let's say outside of this class, yes, you can use it without creating of object. So let's say I'm not creating any object. I'll just comment this line. So I'll print like this, print data loader dot default batch size. So now you will be able to access this data 32. So whatever attributes you are defining as a class attributes or class variables, they can be directly accessed outside of the class using class name. So you no need to create any object. If you need, you can access it directly also. If you want to share across, you can use, let's say you have 20 methods written here, and all 20 methods can use this data. This data is available to share across. Now let's suppose if I want to change it, I want to change an init. So I'll say like this data loader dot default batch size from 32 to 64. So I modified the class variable here, and then I'm calling data loader. So if you see, this is an init, so constructor. So whenever I create the object, now dl1, I created the object. So whenever I create the object, the init gets automatically called, and the value of default batch size is changed now. So if I run it, if I access load data and run it, see the output, the value has changed. So you can change the value of the same variable in this way in any of the method. So it's like you can think, when we have studied about the functions, we have a global variable versus local variable. Same thing here. So I can say the class variables are those variables or attributes which is associated with the class. You can use it using class. And the instance variables are those variables which is associated with your instance, with your object. That is object's property. And this is class property. This is class state. So you can create n number of variables here. So this is the space for you to create the class variables. So let's understand first instance method, which you have already used. So let's say I created a class model, and now I'll have here constructor init. This is constructor, and self, let's say name, comma version. These are the two extra field I am expecting when I'm creating the object. And then I'll say self.name equals to name, self.version equals to version. So now let's say I'll create a method, let's say predict. So this method, predict method, is instance method because the first variable of this method is reserved for the object reference. Instance method, or we call object method, both are same thing. So now if you see this predict method, where the first uh, argument is referred to your instance or object, and then this is another variable. So if I create object m1 equals to, let's say, model, and in model I am passing the name of and name and version, let's say model A, or maybe you are using any model, you can pass that. And then once you created the object here, model A and 1.o will be assigned to these two variables. Self.name will become model A and version will become 1.o. Now this method is instance or object method because I'm calling this method using this instance. So without creating instance or object, I cannot access this. So m1 dot predict, and then I'm passing the value of data, let's say sample data 1. So if I run it, yeah, so that was the older terminal. So if you see here now, I has created an object m1 and I call the predict method, which is instance or object method, with the sample data 1. Now here this data is passed, and when we print it, predicting a model with model A and version 1.0. So these variables are instance variables or object variables we are accessing. So whatever methods you define, let's say if you define another method, def evaluate. So this is evaluate method. Again, it's a object or instance method. So you are calling this method using object. So if I talk about the properties of object, we are using all three properties now. One is it has a unique name, yes. The ID, it has attributes. So if you see, name and version are the attribute of the object here. It has, the third one is it has some behavior. So the behavior of the object is predict and evaluate. Behavior is nothing, it's a methods. So method of object in this class are predict and evaluate. So this is called um, method, or like the methods of instance or object. So you have already used it. Now let's see how we can create class methods. So I'll create another method in this class. Let's say I'll have one method like this, def from config. And this method is nothing, just we are loading some model with default config, or let's say from a configurations. We are just setting the configurations, right? And let me just not make it more complex. I'll just create simple print statement here. I'll say print creating a model config, and then I'll not use this also. So just the simplest. So what this from config method is, so we need to create a class method. So to create the class method, first thing is you need to decorate it using class method. This is a decorator. So this decorator means we are saying that whatever method we are creating, and if you are decorating that method with class method, those methods will be considered for the class. So let's say from config, and here in from config we are passing CLS. So class method also says if you are defining any class method, the first variable of the method will be reference to the class. Similar like object. Object method says whenever you are creating an object method, the first argument of the method will represent of the object will represent object. So I'll explain it again. So this is the only difference. So let's try to access it. The beauty here is I will be able to access this method in two ways. One is, let's say, using class name model dot from config, and I pass some config here. It's just a dictionary, right? So I'm just printing it here. So this config value will be assigned. This is the value will be assigned to config. Now if I print it, see the output. So we are able to call this method using class. So no need to create the object. Let's say if I'll not have this object also, then you will be able to use it. Like similar like let's say I'll create it like this. So similar like you have class attributes. Similarly, we have class methods. So you can create some methods which can directly be called using class without creating object. And if you are creating object, let's say I created the object M1, then your object is also having authority M1 dot from config. So you can say model A, and we are passing some version here. So you can call it. So if you correlate here, again, your object has the capability to use its own method, and it can use the class method also. But it cannot go in reverse way. Let's say if I try to access predict method using class name, not the object. So I'll say model dot predict, and I'll pass some sample here. So first of all, I'll not pass M1 because I haven't created it. Just consider that. So see the output, it returns an error. It says it expects one positional argument. So what is that argument? Self. So it expects that. So you can call instance method using class name, but the condition is there should be an object created to it first. So you can pass the object here because we have created M1 here. So you can pass the object M1, and this object will represent self here now. M1 is the reference. So now see this works. So let me take a screenshot of it, and again I will explain. So let's understand. So we have created a class here, model class, right? And this is the constructor. And whatever variables you create in constructor using self, those variables are object variables, right? Or object attributes. This is clear. Now, the method which you are creating within the class, and there is no decorator at all, those methods are called object method or instance method. Instance or object method. So there are two ways like you can identify. One is there is no decorator at all. Another is the first argument of the method is reserved. So this is reserved for object. So if you want to call, predict or evaluate any of the method, you need at least one object to be created. That is a condition. Then only you will be able to access it. So if you see here, we created an object M1 and then we are able to call predict and evaluate. And if you are trying to access these two methods using class, you can do that, but it asks for passing the object. So using class name, you can call the method of instance, but you need to pass the instance for reference. So what it does, this object will be pointing to self because again it is expecting one reference, object reference. So this is the reference which we have said to that this class using predict using this object, and then you can pass the values of those arguments. So that is one of the condition. So this is about the object method or instance method. Now how the class methods are different from instance method. First thing is you need to define a decorator. This is the syntax which you need to follow. And then there is another condition. Whenever you define a method, class method, let's say from config is a class method. The condition is the first argument, again it is reserved. But this is not, this time this is not reserved for your object. This is reserved for class. That is the only difference. In both the thing, the first argument is reserved. So whenever you create a class method, always you need to pass one variable. This variable can be anything, not only CLS. CLS is just for more readability like self. You can pass any variable to it. So this is class reference. Now after this variable, you can pass n number of variables here, the arguments. So as of now, I have created one argument config. Now how you can use this without creating object, even though you don't have M1 here, you can directly call it using class name. So class name is model dot from config, and the data whatever I'm passing here is a single object. So this is a dictionary. So this dictionary is assigned to config, not to CLS, because CLS is reserved. Now you are able to access it using class without creating object. That is one benefit. Another way is if you want to call this method, the class method using object, yes, you can do that. So m1 dot from config, you can pass the data here and you will be able to use class methods also. Similar like class attributes. So let's say if I want to print CLS here, we will understand what exactly it is. So it will print here. One second, it is too confusing. I'll just comment couple of lines here. See here, class. This is the class, model class. So if I print self, it will give you an address. So that is a difference. Like class don't take memory, object takes the memory, or right, it has a reference, the address. There is a difference between class and object. So until we have covered instances and class attributes, object creation and inspection, we have covered the life cycle of object, then instance method and class methods. So in next class, we will discuss about the static methods and inheritance. Thank you.